Example 102 says, set up an integral for the area bounded by y equals 1, y equals 1 over x, and x equals 2, and rotate it around the line y equals 1. And then use a calculator to approximate it. All right, so first up, we want to graph this area. We could use a computer, but I'm not going to. I'm just going to graph it by hand. Because y equals 1 over x, let's graph it up here roughly. Y equals 1 over x looks like that. Y equals 1 is a line here. X equals 2 is a line over here. So we're really looking at this. So let's see, this point up here is 1, 1. And this goes down over here to 2, 1/2. And we're actually rotating this around the line y equals 1. So let's take this, move it down, and let's erase that. So we're rotating the area around here. This is the area we're talking about. So if we rotate that around the line y equals 1, this is going to be the reflected part of it. And it's going to be shaped kind of like a bullet or something. And we want to set up an integral for this. So let's draw in a disk. All right, so the disk is going to be like this. And we got to come up with the thing's radius and its thickness. And I've already made one mistake here. When I draw the radius, I don't want to draw it to the reflection. You always want to draw the radius from the center down to the, or I shouldn't say down, from the center back to the original graph. Reason being, right here, this is, let's see, this is my axis here. So this is x. I need coordinates for this point and for this point. This point has x coordinate x, and its y coordinates 1 over x. This one up here has x coordinate x, and its y coordinate is 1. All right, so we need to find the length of that purple line, the radius. And we can get that by doing 1 minus 1 over x. And the thickness of this thing is going to be dx. All right, so that means that the volume of this thing is going to be pi times the integral of the radius squared times dx. And what are our endpoints here? Well, the way you get the endpoints is you go back to the original area and you go from one end to the other. Now we're doing this with respect to x, so we're going from here to here. And so we need the x coordinate of this point, the x coordinate of that point. Now x coordinate of this point here is 2. X coordinate of this point, I had it labeled before, but I erased it, is 1. So we're going from 1 to 2. And since this problem only asked us to set this up as an integral, I'm going to write that and call it done. It then says use a calculator to approximate the area. Let's do this 2 ways. First up, let me show you how to use Desmos to do an integral. If you go over here to Desmos, let's see. The integral we had is pi times integral. Just type in int and it gives it to you. From 1 to 2 of 1 minus 1 over x squared dx. And it gives us that for the area. Oh, I'm sorry, the volume. Looks good. Let's also look at this on here. Now we said, what was this? This was y equals 1 over x. Let's zoom in on it. So we're supposed to go y equals 1 over x. Let's unshade that area for now. And g of x is 1. So there's the little area that we're interested in. Okay, it's not shaded. So what do we need to do here? Let's put 1 on top since that's the upper one. Then 1 over x here. And our endpoints are supposed to go from 1 to 2. So now I've got the correct area shaded. All right. Now, the way I'm moving this is I'm right-clicking and sliding it. So now my axis of rotation is supposed to be the line y equals 1. So I do that. Notice the black line shows up there. And then if I rotate it, it gives us this shape that we were looking for. This, I said it was a bullet shape earlier, but it kind of looks like the front of a blimp or something. And let's see. Notice the volume it gives us here, 0.3572. That's the same thing as Desmos gave us. And if we wanted to, I mean, this is not a difficult integral to do. We could easily do this with, we could easily work it out exactly. All we'd have to do is square out the, just square this out and go. Before we leave, though, before we leave this example, I want to play with the computer a little bit. Because this is rotating around the line y equals 1. What if we rotated around the line y equals 2? Well, if we rotate around there, we're going to get this big thing. And if we rotated around something below, let's say we rotated around y equals y equals 1. Oh, we did that already. Y equals 1/2. If we do that, we get this. It looks like a cylinder from this side, but it's not a cylinder, or at least it's not a solid cylinder. It's got a an indent in it, and you can see that better if you turn the opacity down. Especially if we turn it down and maybe cut this back to 10 of these. All right. So anyway, this can be a fun thing to play with. But anyway, that's how we'd set that up. We'll pick up. Well, I want to also look at doing disks around a vertical axis, and we'll do that in the next video.